According to the National Electrical Code, there are restrictions regarding the direct burial of any electrical cable in the same trench as piping for gasoline dispensing pumps in Class 1 Division 1 or Division 2 areas. National Electrical Code Article 514.3b states that electrical equipment shall not be installed or have electrical connections in a trench or duct containing steam pipes, hot water pipes, or other sources of high heat unless the cables and conductors are specifically approved for the conditions. While the NEC does not specifically reference XLPESWA cable, it is a type of cable that can potentially meet the requirements outlined in NEC Article 514.3b, assuming it's rated appropriately for the conditions. XLPESWA stands for Cross-Linked Polyethylene Insulated Steel Wire Armored Cable. It is generally designed for use in underground applications and offers resistance to heat, moisture, and chemicals. EXE glands are explosion-proof cable glands. These glands are used to seal the connection between a cable and an enclosure. They are often used in hazardous locations to prevent the ingress of flammable gases or vapors into the enclosure. EXE glands can be used to seal the connection between XLPESWA cable and an enclosure in a Class 1 Division 1 or Division 2 area. This practice can potentially meet the requirement of NEC Section 514.8b, which states that enclosures for electrical equipment in Class 1, Division 1 locations shall be provided with a means to prevent flammable vapors from entering the enclosure. To summarize, directly burying XLPESWA cable in the same trench as piping for gasoline dispensing pumps in Class 1 Division 1 or Division 2 areas is generally not permitted unless specific conditions are met and the installation adheres strictly to NEC guidelines. The use of XLPESWA cable might be acceptable in these areas if it is properly sealed with an EXE gland, provided the entire assembly is approved for the hazardous location. It is important to consult with a qualified electrical inspector or engineer to ensure that any electrical installation meets all applicable requirements and regulations. The key is to ensure that the entire system, including the cable, glands, and any associated enclosures, is rated and approved for use in the specific hazardous location. Always refer to the latest edition of the NEC and any local amendments for the most up-to-date requirements. Additionally, ensure that all equipment is properly listed and labeled for its intended use. When working in hazardous locations, safety is paramount. Proper installation techniques and adherence to all applicable codes and standards are essential to prevent explosions and other hazards. Always use qualified personnel and follow manufacturer's instructions for all equipment. When dealing with electrical installations in hazardous locations, such as those around gasoline dispensing pumps, it is crucial to understand and adhere to the requirements of the National Electrical Code, specifically Article 514 and related sections. These areas are typically classified as Class 1, Division 1 or Division 2 locations, indicating the presence of flammable gases or vapors. Therefore, all electrical equipment and wiring methods must be suitable for these hazardous conditions to prevent explosions and ensure safety. The NEC provides detailed guidelines on acceptable wiring methods, equipment, and installation practices for these locations. One common wiring method is the use of rigid metal conduit with explosion-proof fittings, which creates a sealed pathway to contain any potential explosions within the conduit system. Another approach involves the use of intrinsically safe circuits, which limit the energy available in the circuit to a level that cannot ignite flammable substances. The selection of appropriate wiring methods and equipment depends on the specific conditions of the location and the type of hazard present. It is essential to consult with a qualified electrical engineer or inspector to determine the best approach for each application. Regular inspections and maintenance are also crucial to ensure the continued safety of electrical installations in hazardous locations. Any signs of damage, corrosion, or deterioration should be addressed promptly to prevent potential hazards. Proper training and awareness among personnel working in these areas are also essential to ensure safe work practices and prevent accidents. In addition to the NEC, other standards and regulations may apply to electrical installations in hazardous locations, such as those issued by the Occupational Safety and Health Administration or local authorities. It is important to be familiar with all applicable requirements and ensure compliance at all times. Working in hazardous locations requires a high level of expertise and attention to detail. By following the guidelines and best practices outlined in the NEC and other relevant standards, it is possible to create a safe and reliable electrical system that protects people and property from the dangers of explosions and other hazards. When working with XLPESWA cable and EXE glands in hazardous locations, several factors must be considered to ensure a safe and compliant installation. Firstly, the XLPESWA cable itself must be suitable for the specific hazardous location. This means that it must be properly rated for the temperature, chemical exposure, and mechanical stresses that it may encounter. The cable should also be listed and labeled by a recognized testing laboratory, such as Underwriters Laboratories, to verify that it meets the applicable safety standards. Secondly, the EXE glands must be properly selected and installed to provide a flame-proof or explosion-proof seal around the cable entry point. The glands must be compatible with the cable type and size, and they must be installed according to the manufacturer's instructions. Proper tightening of the gland is essential to ensure a tight seal that prevents the ingress of flammable gases or vapors. Thirdly, the enclosure to which the cable and gland are connected must also be rated for the hazardous location. The enclosure must be strong enough to contain an internal explosion without rupturing or allowing flames to escape. It must also be properly grounded to prevent the buildup of static electricity. Fourthly, the entire installation must be inspected and approved by a qualified electrical inspector to ensure that it meets all applicable codes and standards. The inspector will verify that the cable, glands, and enclosure are properly selected, installed, and grounded. They will also check for any potential hazards, such as exposed wiring or damaged equipment. Finally, it is important to maintain the installation properly over time. Regular inspections should be conducted to check for any signs of damage, corrosion, or loose connections. Any problems should be addressed promptly to prevent potential hazards. By following these steps, it is possible to safely and effectively use XLPESWA cable and EXE glands in hazardous locations. However, it is important to remember that working in these areas requires a high level of expertise and attention to detail. Always consult with a qualified electrical engineer or inspector if you have any questions or concerns. The NEC is a comprehensive document that provides detailed requirements for electrical installations in various locations, including hazardous locations. It is updated regularly to reflect changes in technology and best practices. Therefore, it is essential to stay up to date with the latest edition of the NEC and any local amendments. The NEC is organized into chapters, articles, and sections. Each section covers a specific topic, such as wiring methods, equipment, or installation requirements. The NEC also includes tables and figures that provide additional guidance and information. To use the NEC effectively, it is important to understand its organization and how to navigate its various sections. The index is a valuable tool for finding specific information. It is also helpful to use keywords and phrases when searching for relevant sections. When interpreting the NEC, it is important to consider the context of the section and its relationship to other sections. The NEC is not intended to be read in isolation. It is important to consider the entire code when making decisions about electrical installations. If you have any questions about the NEC, it is best to consult with a qualified electrical engineer or inspector. They can provide guidance on the proper interpretation and application of the code. The NEC is a valuable resource for ensuring the safety and reliability of electrical installations. By understanding and following its requirements, it is possible to prevent electrical hazards and protect people and property. Firstly, understanding the specific requirements for Class 1, Division 1 and Division 2 locations is paramount. These classifications define the likelihood of flammable gases or vapors being present. Division 1 indicates that the hazardous substance is present continuously, intermittently, or periodically under normal operating conditions, while Division 2 indicates that the hazardous substance is present only under abnormal conditions such as a spill or equipment failure. Secondly, selecting appropriate cable and sealing methods is crucial. XLPESWA cable, while robust, must be properly terminated with explosion-proof glands, EXE glands that are specifically designed and certified for use in Class 1, Division 1 or Division 2 locations. These glands create a flame path that cools escaping gases, preventing ignition of the surrounding atmosphere. Thirdly, proper installation techniques are essential for maintaining the integrity of the explosion-proof system. This includes ensuring that all connections are tight, that the grounding is adequate, and that the cable is supported properly to prevent strain on the gland. Fourthly, documentation and labeling are vital for ensuring compliance and facilitating future maintenance. All equipment and wiring should be clearly labeled with its hazardous location rating and any other relevant information. Finally, regular inspections and maintenance are necessary to ensure that the explosion-proof system remains effective over time. This includes checking for any signs of damage, corrosion, or loose connections, and replacing any components that are not in good working order. Consulting with a qualified electrical engineer or inspector is highly recommended to ensure that all aspects of the installation comply with the NEC and other applicable standards. These professionals can provide valuable guidance on selecting appropriate equipment, designing the electrical system, and ensuring that the installation is safe and compliant. In addition to the NEC, other standards and regulations may apply to electrical installations in hazardous locations. These may include standards issued by the Occupational Safety and Health Administration, the American Petroleum Institute, or other organizations. It is important to be familiar with all applicable requirements and ensure compliance at all times. The use of XLPESWA cable and EXE glands in hazardous locations is a specialized area of electrical work. It requires a high level of expertise and attention to detail. By following the guidelines and best practices outlined in the NEC and other relevant standards, it is possible to create a safe and reliable electrical system that protects people and property from the dangers of explosions and other hazards. Also, it's important to consider the mechanical protection of the cable. While XLPESWA cable offers inherent mechanical protection due to its steel wire armor, additional protection might be required depending on the specific installation environment. This could include burying the cable deeper, encasing it in concrete, or using a conduit to protect it from physical damage. Furthermore, it's crucial to ensure proper grounding and bonding of the cable and associated equipment. Grounding provides a path for fault current to flow back to the source, helping to trip over current protective devices and prevent electrical shock hazards. Bonding ensures that all metal parts are at the same electrical potential, reducing the risk of sparks or arcs that could ignite flammable substances. The selection of appropriate grounding and bonding methods should be based on the requirements of the NEC and other applicable standards. Finally, it's important to consider the potential for corrosion in the installation environment. Gasoline and other chemicals can be corrosive to certain metals, so it's essential to select materials that are resistant to corrosion. This could include using stainless steel conduit and fittings or applying a protective coating to the cable and equipment. Regular inspections should be conducted to check for any signs of corrosion, and any corroded component should be replaced promptly. By taking these additional factors into consideration, it's possible to create a safe and reliable electrical installation in a hazardous location. However, it's important to remember that this type of work requires a high level of expertise and attention to detail. Always consult with a qualified electrical engineer or inspector if you have any questions or concerns.